Good day everyone. Let's try to answer some item on Bulgarian Mathematical Olympiad on 2007. And let's start. Here's the question. Solve in Z, wherein Z is the set of integers. We have 8 raised to x minus 2 raised to x all over 6 raised to x minus 3 raised to x equals 2. Now, if you want to try this problem, just pause this video, and if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. Our goal to this question is to solve for the value of x, and we know that x is an integer. To start with, notice that 8 can be written as 2 cubed. Therefore, we have 2 cubed raised to x minus 2 raised to x all over 6 raised to x minus 3 raised to x equals 2. Now at this point, we will use some laws of exponent. If we have b raised to n raised to m, it is equal to b raised to n times m. Therefore, our numerator becomes 2 raised to 3x minus 2 raised to x. Now at this point, we can factor out 2 raised to x on the numerator and 3 raised to x on the denominator. If we do that, we get 2 raised to x multiplied by 2 raised to 2x minus 1. On the denominator, we have 3 raised to x multiplied by 2 raised to x minus 1. 3 raised to x times 2 raised to x will give us 6 raised to x. Next, on the numerator, 2 raised to 2x minus 1 can be factored using difference of two squares. So if we have a squared minus b squared, it is equal to a plus b multiplied by a minus b. Therefore, our numerator becomes 2 raised to x multiplied by 2 raised to x plus 1 multiplied by 2 raised to x minus 1. Now at this point, we can now cancel out 2 raised to x minus 1 on the numerator and the denominator, provided that we set that x is not equal to 0. Why is that? Because if x is equal to 0, we have 2 raised to 0 minus 1, and 1 minus 1 will give us 0. So we have 0 over 0, and we don't want to have 0 over 0 because it is indeterminate. Therefore, we need to set that x is not equal to 0. So at this point, we can now cancel out 2 raised to x minus 1 because we know this is not anymore 0 over 0. Therefore, we have 2 raised to x multiplied by 2 raised to x plus 1 all over 3 raised to x. Multiply by 3 raised to x both sides, and we get 2 raised to x multiplied by 2 raised to x plus 1 equals 2 times 3 raised to x. Next, divide both sides by 2 and we have this equation. Now at this point, we will use some laws of exponent. If we have b raised to n all over b raised to m, it is equal to b raised to n minus m. Therefore, we have 2 raised to x and 2 raised to 1. It follows that we have 2 raised to x minus 1 multiplied by 2 raised to x plus 1 equals 3 raised to x. Now, what will happen if x is greater than or equal to 2? The left-hand side is always an even number because we have a factor of 2. And the right-hand side is always an odd number. Therefore, the left-hand side is even, the right-hand side is always an odd. Therefore, we don't have any solution if x is greater than or equal to 2. Now, at this point, we know that we don't have any solution if x is greater than or equal to 2, and we know that x cannot be equal to 0. In between them, there's a 1. Now, let's see what will happen if x is equal to 1. Now, substitute x equals to 1, and we get that 2 raised to 1 minus 1 multiplied by 2 raised to 1 plus 1 equals 3 raised to 1. So all those x's becomes 1. Next, simplify, and we have 2 raised to 0 or simply 1. 1 times 2 raised to 1 plus 1 is 3 equals 3 raised to 1. 1 times 3 equals 3. Definitely 3 is equal to 3. Therefore, we can say that x equals 1 is one of the solution. And here's our claim. Our claim is x equals 1 is the only solution. Now, to prove that, we need to show that there's no other solution if x is less than or equal to negative 1. So let's do that. At this point, our claim is the only solution to this equation is just x equals 1. And here's what we know. We know that x cannot be equal to 0. And we have no solution when x is greater than or equal to 2. Now our goal is to show that there's no other solution other than x equals 1. So we need to show that no solution when x is less than or equal to negative 1. Now to do that, we need to let x be equal to negative n, or a negative integer. If we do that, we have our equation now becomes 8 raised to negative n minus 2 raised to negative n all over 6 raised to negative n minus 3 raised to negative n equals 2. Now simplify, 8 becomes 2 raised to 3, so therefore we have 2 raised to negative 3n. Next, factor out 2 raised to negative n on the numerator and 3 raised to negative n on the denominator. If we do that, we get 2 raised to negative n multiplied by 2 raised to negative 2n minus 1 all over 3 raised to negative n multiplied by 2 raised to negative n minus 1 equals 2. Do the same thing, we can factor out 2 raised to negative 2n minus 1 because it is the same thing as 2 raised to negative n raised to 2. Therefore, we can use difference of two squares. We have a squared minus b squared. It is equal to a plus b multiplied by a minus b. Therefore, our numerator becomes 2 raised to negative n multiplied by 2 raised to negative n plus 1 multiplied by 2 raised to negative n minus 1. Now at this point, we can cancel out 2 raised to negative n minus 1 on the numerator and the denominator if we set n is not equal to 0. Because again, if n is equal to 0, 2 raised to negative n minus 1 becomes 0 and we have 0 over 0. And we don't want to have that one. Therefore, we need to set n is not equal to 0. So we can now cancel out 2 raised to negative n minus 1. And we have 2 raised to negative n multiplied by 2 raised to negative n plus 1 all over 3 raised to negative n equals 2. Next, I don't want negative exponent, so we need to replace negative exponent by a positive exponent. So we know that b raised to negative n is equal to 1 over b raised to n. So we can replace 2 raised to negative n by 1 over 2 raised to n. And 3 raised to negative n, we can replace by 1 over 3 raised to n. If we do that, we get 1 over 2 raised to n multiplied by 1 over 2 raised to n plus 1 all over 1 over 3 raised to n equals 2. Now simplify a little bit and we have 3 raised to n multiplied by 1 plus 2 raised to n all over 2 raised to 2n, and it is equal to 2. Next, multiply by 2 raised to 2n both sides, and if we do that, we will use some laws of exponent again. If we have b raised to n times b raised to m, it is equal to b raised to n plus m. Therefore, we have 3 raised to n equals 1 plus 2 raised to n equals 2 raised to 2n plus 1, because the exponent of 2 is simply 1. Therefore, 2n plus 1. Now at this point, what will happen if n is greater than or equal to 1? Notice that the left-hand side is always an odd number and the right-hand side is always an even number. It follows that if we try any values of n greater than or equal to 1, the left-hand side is always an odd number and the right-hand side is always an even number. Therefore, an odd number cannot be equal to an even number. What does it mean? It follows that we don't have any solution when x is less than or equal to negative 1. Therefore, the only solution to our question is simply x equals 1. And we're done.